have our law of sines with your side-to-side angle scenario. Anytime that you have a side-side angle, that means that we have 0, 1, or 2 possible triangles. So we're going to start this problem out by assuming that we have 2 triangles. So I'm going to go ahead and list my information for triangle number 1 and triangle number 2. Now in in both of these you have angles A, B, and C. And you also have sides A, B, and C. So I look at my triangle and I figure out what we already know. We know that angle A is 58 degrees. So it's 58 degrees in both triangles. We also know that side B is 5 in both triangles. And we know that side A is 4.5 in both triangles. So that's our first thing. We're going to assume that we have 2 triangles. We have identified the information in both. Now we're going to go ahead and just start solving the triangle. We notice that we have our angle and opposite side combination. That means that we can use law of sines. So we start out by saying sine of 58 degrees over its opposite side of 4.5 is equal to sine of angle B, because we have side B, which is 5. From here we cross multiply. Let's see. So 4.5 times sine of angle B equals 5 times sine of 58. We want to solve for angle B, so we're going to divide both sides by 4.5. And from here we take our calculators to see what sine of angle B is. So when you calculate that, you get a decimal of 0.9423. So to figure out what angle B is, this is where we use our inverse sine button of the 0.9423. And when you do inverse sine of that, we get angle B is equal to 70.4 degrees. So that first angle that we find is going to be an angle in our first triangle. So we know that B is a 70.4. So here's where we test to see if we have a second triangle. If angle B in triangle 1 is 70.4, that means that angle B in triangle 2 is going to be supplementary to that. So we'll take 180, subtract the 70.4, and we get 109.6. And from here, we're going to look to see if we have a second triangle that exists. If we notice our second triangle has angle A is 58 degrees, angle B is 109.6 degrees, do we have room in our triangle for a third angle? So if you add those up and subtract from 180, you get 12.4 degrees, which means that yes, we have a third angle, so we have a second triangle because we could fit 3 angles in that second triangle. So what that means is that we have 2 triangles to solve for. If I kind of backtrack for a second and go back to my triangle 1 and finish this one up, since that's what my drawing matches up there, we can get our angle C and our side C. Angle C, when we add the 2 angles and subtract from 180, we get 51.6 degrees. And then to get side C, we'll just go back and do law of sines. So if I go ahead and erase what I have there, set up law of sines, I'm going to stick with that sine of 58 over 4.5. It's going to be equal to, now I want side C, so I'm going to do sine of angle C, which I now know is 51.6 over side C. And then you're going to cross multiply, solve for C, and we get C is equal to 4.2. And then the only thing we need is side C from triangle 2. Now for triangle 2, we just need to use different information. I can use angle A is 58 degrees, so sine of 58 over 4.5 is equal to, since we need side C, I'm going to use sine of angle C, which is 12.4 over C. And then we would cross multiply and solve for C, which is 1.1.